I've stripped the motor down. It was quite difficult to get apart because some of these tie rods had bent up inside the motor and I've had to chop them off. So I think I've got two that are salvageable. But I'll have to make two more to replace those. So we've got the fan cowl, the fan, the end cap of the motor, the stator of the motor, the rotor of the motor, the other end cap with some kind of dust guard, and then the pulley. That seems to have a left-handed Whitworth thread in it. I managed to snap the bolt taking it off because I didn't realise it's left-handed. So I'll either have to drill it out and tap it, or source the bolt. So I'll clean this up, paint it, put it together, make some new tie rods, and decide what I do with the bolt on the front there. There were some spaces between the end cap and the cowl on the end. These are two that I've just faced off the end there in reasonable condition. One was missing and the other one got very mashed up trying to take it off. So I've made one replacement and I'm in the process of making a second. So I've checked the thread on the end of these tie rods and they're 3/16 BSF. So I managed to find a 3/16 BSF die in the drawer. So I'm just putting a thread on the end of these tie rods. So I've just chopped them off and faced them on the lathe. Now I'm chamfering them and putting a thread on the end. The motor cowl was pretty bent up, so I've taken it over to this dolly and just hammered it around, take all the main dents out of it. So that's, I just need to clean up and then I can paint that. All the components have been primed and then filled and sanded, and they've now had their first coat of grey enamel. So I'll give them another coat and see what they look like. I'm not particularly interested in making this a museum piece. It's going to be a grinder that's going to be used, but it's, while I'm taking it apart, I might as well paint it. So all the parts are now, top coat is now sanded down. We're going to give the parts their final coat. The bellows on this grinder are pretty worn. This is the main column bellows. You can see they're leather bellows, and while this piece looks okay, it's really perished and all the stitching's gone rotten in it. So I'm going to remake these bellows. I did wonder about which method to use, whether I could make them in leather. I couldn't find any sort of commercially available bellows without spending a huge amount of money. So unfortunately I've got to remake them. I'll reuse the original steelwork either side. So that's going to be a long and tedious job. So I've made a template for each bellow section, and I've checked this for fit against the column. So this will make each of the parts of the bellow that I'll then glue together. The material I chose was nitrile. This is an example. You can see you basically glue the inside and then the outside alternately and create a bellows. This material is quite good because it's resistant to oil, and so it should be suitable for the job. Super glue is actually quite good at gluing nitrile together, so it's just glued together with simple super glue. I mean, we'll see how durable that is, but it seems to work quite well on this little trial piece that I've made. It's quite tough. So this is the partially complete bellow. You can see the nitrile sections there and the alternate gluing. Quite hard to do with one hand. You can kind of get an idea of how that works. So what I'm going to do now is clean up the metalwork on the old bellows and affix them, and then we can start the rest of the assembly. So I'm rewiring the grinder. You can see there is a modern contactor, and the silver thing is the original switch and fuse box, and then I have the original contact switches at the top there. So this little circuit diagram shows the electrics on this. You have the incoming 3-phase from the phase converter, the isolator switch, the original fuses, then the 3 phases coming into the contactor. We've got the coil, the auxiliary contact, and then as part of that loop we've got a normally closed stop switch and a normal open start switch. So this red part here is original, and the 2 switches are original, but the contactor is new. So the motor is a 3-phase, half horsepower, dual voltage motor. It was wired up for 220 volts, so I rewired it in star for 380, 440, so I can run it off my phase converter that I built. So that was a bit of a pain because I didn't know which colours went to where, but thanks to the Mad Modder site I got that clarified. So the final alignment exercise is to make sure that the axis of the spindle is perpendicular to the table travel. So what I've got is a mag base fixed to the spindle there, with an indicator on it, and then simply rotating it around. So that change hands here. So that it registers against the scrape surface. I've got a little bit to go yet. But what I have here is one of the dowels in place. The machine only came with one dowel, and then the screw's not fully tightened up. And I'll knock this with a soft mallet either way to make sure that's finely aligned, and then that's the grinder complete. So this is the grinder completed. You can see we've got the bellows fitted to the bottom of the new bellows. The new bellows I made on the top. We've got a coat of paint on it. Got both guards fitted. The original switch there that I rebuilt. The original isolator and a new contactor. The rebuilt motor, and a new grinding wheel on there. So next job is to mount the chuck, dress the grinding wheel, and try our first cut. This was the comedy oversized chuck that came with the surface grinder. It's a good chuck, but it's just too big for the machine. It's 10 inches long and the machine only has a travel of 7 inches, so you can't clean the whole top of this chuck up in one pass on the machine. I had a much more suitable chuck for the job. I bought this for using on that little tool and cutter grinder, but it was a bit too big for that, but it's ideal for this. So I've used the original clamping down dogs. It fits on there nicely.